All right. Our second speaker today is going to be Guoqing Diao, who is a professor in the Department of Biostatistics and Bioinformatics at GW, George Washington University. His research interests include parametric models, survival analysis, meta-analysis, causal inference, clinical trials, and drug safety signal detection. You and I need to talk after this. More recently, he's also been interested in sports analytics. And take it away, Guoqing.
Thank you very much for the introduction. This is the first time I attended this conference. Unfortunately, my alma mater name was mentioned multiple times. I'm not really proud of it. UNC Chapel Hill, I was embarrassed by all those unnecessary drama. It's not very good. Anyway, so I actually was trained as a biostatistician, so you probably wonder what are you doing here. Well, this is the first time I attended this type of conference. I never did any research on this topic in this area, except for this one. So this is really new to me. So I want to thank this fellow because that's how I got into this area. Also, that's Matthew. He played a game against Fabiano Caruana. I don't know if you know him. At the time when he played Fabiano was U.S. #1 in chess and world #2. And then he dropped the rating a little bit. And now I think he's U.S. #2 world maybe. Yeah, he dropped a lot in world ranking. So my son plays competitive chess, and his hobby is to play chess. So he reads news on chess.com, and he watches those like famous YouTubers who play chess. So probably around 1 year ago, maybe 11 months ago, and during dinner time, he was talking to me, so Dad, do you know this professor? He's a famous professor, famous statistician, Jeffrey Rosenthal. He wrote a report for chess.com, and chess.com news reported, etc. Oh, really? This professor wrote a report for chess.com. I was very intrigued. So I said, well, that's interesting. I'm going to check it out. So that's what happened. And then I read Professor Rosenthal's paper report, and I think, well, this is a very interesting problem. And then I did some work while I was waiting in the hotel lobby when my son was playing chess. He's competitive. In October, he will get his official FIDE master title. Well, so the story is about another very famous grandmaster in the U.S. So Fabiano Caruana, very famous, and Hikaru Nakamura, I think probably is more famous because he has a very popular, Twitch channel or YouTube channel. So a lot of kids watch his YouTube videos. I don't think Fabiano Caruana does that. So he's very popular among those kids. And also recently he was involved in another controversy because in order to qualify for the candidates tournament to compete for like world champion, he needed to meet certain requirements. So for example, you need to meet the requirement of your rating. Also, you need to meet the requirement to have played certain amount of game. But nowadays, this kind of grandmasters, they don't really play many classical games. So what he did is that there's this loophole in FIDE rule. So he attended the quote-unquote Mickey Mouse tournament. So those very small tournaments. And some people criticize him for farming ratings over those very low rating players. But it turns out the overall reaction was very positive. The tournament organizers was very happy. And all those players who played him, They were all very happy about it. Imagine a high school kid who plays tennis and he got the chance to play Carlos Alcaraz or Yannick Sinner. Of course, they will go for it. So everybody was happy except for some of those, they think, yeah, he's farming like ratings. Because, of course, he won all the games and he gained like 0.8 points in rating for every game because everybody's rating is much, much lower than him. But there's still risk. You may get upset, and then you will lose a lot of rating. Anyway, so this is a very, very famous grandmaster. And my son is a fan of his, and he watches his YouTube videos all the time. Well, the thing that when he started playing chess on this very popular platform, chess.com, how many of you played chess or played on chess.com? Wow, more than I expected. I don't really play, but I solve a puzzle every day. There's a daily puzzle, and the difficulty level increases from Monday to Sunday. Sunday is the most difficult one. Well, so Hikaru Nakamura has quite a few very impressive non-winning streaks. So now, like in 2016, he had winning streaks of 54 games. He's won all 50 games in a row. And then in 2018, he had another streak. This is not exactly all winning, but he only drew one game out of 57 games, etc. So he has a lot of very long winning streaks. I asked myself, what's your winning streak? Probably like 10 also, so of course much, much lower. And then there's this famous grandmaster who was actually very solid, very good before because he was the former world champion from, I think, 2000 to 2006. Grandmaster Kramnik posted on chess.com. He said, well, having checked Hikaru's statistics carefully, I have found numerous low probability performance, both of him and some of his opponents. So his argument is, I think, well, if you assume independence and take a look at the individual probability of winning a game and then assume independence, you multiply those probabilities, you will get a very, very small number. So that's his argument. It's mathematically impossible for Nakamura to have so many winning streaks. So this is the timeline. Of course, I cannot list all of them, and there are a lot of discussions online in the chess community. And chess.com later on issued a statement. They mentioned that they ran a lot of like fair play reports, and they didn't find any issue with Nakamura's game. So they don't think Nakamura cheated. And then New York Times added fuel to this controversy. They published an article. Indeed, chess players keep accusing each other of cheating. Because some of you probably know during that time there was some other controversy. We will get into that. And then a few researchers, I think two of them from University of Chicago, one from George Mason University, they posted an archive manuscript, Kramnik versus Nakamura, a chess scandal. So what they did, they used some kind of Bayesian approach, and they claim that Nakamura has a 99.6 chance of not cheating. But Kramnik was not convinced. He doubled down and says he believes Nakamura is more likely to have cheated than Hans Niemann. Hans Niemann is another very famous, very young, very famous grandmaster, but he has his own share of controversy because he was caught cheating on chess.com and he confessed, but not on the over the board. But Max Carlsen was really mad that he lost to Hans Niemann and he accused him cheating. But I don't think there was substantial evidence there. And then that's a report my son told me about. So Professor Jeffrey Rosenthal published a report, Probability of Streaks in Online Chess. So Professor Rosenthal, before that, because we work on really different areas, so forgive my ignorance, I don't really know him, but then I checked his bio. Wow, he's a genius. He's an absolute genius. He's very famous, and he won the COPS Award many years ago. You know, COPS Award is like a Nobel Prize in our field, and he built the foundation for solving this kind of problem. And he concludes that Nakamura's streaks are actually fairly typical for a strong grandmaster like him. Well, then I wrote this note. That's what we are going to talk about. And then later on, Professor Rosenthal, based on his previous report, and added a lot more details, and published a paper in Harvard Data Science Review journal. Is this a kind of new journal? Probably is, yeah. And reaffirms Nakamura's innocence. But Kremlin wouldn't give up. He files a defamation lawsuit against some other grandmaster, I think from Europe, and also chess.com. They finally issued a statement urged Kremlin to withdraw his defamation lawsuit. And quite a few other famous grandmasters spoke out. In particular, Grandmaster Aronian pays a very emotional plea. We cannot just keep suing each other. It's not good for the entire community. You cannot keep accusing everybody else of cheating without any evidence. All right, so that's the basic storyline for this controversy. It hasn't ended yet. It's still ongoing. We'll see what happens next. But this is actually a probability problem. So between January 2014 and July 2024, Nakamura actually played a lot of games, like almost 500 games, because chess is his profession. He plays on chess.com all the time. My son even played him a few times, of course, all lost. But he had a friend upset Hikaru Nakamura multiple times, and Nakamura was not that gracious either, so he was not very happy about losing to a player like 400 points lower than him. Well, so now the question is, what are the chances for Nakamura to have such a non-winning streaks? So that's the problem. Well, before we talk about all those probabilities, we first need to understand the chess rating system. So as a chess parent, I actually read all those documents. So again, I want to apologize to Mark. I never pay attention to the authors. So Mark actually is like the founding father of the US chess rating system. He chaired the US chess rating committee for many years. So he's instrumental, and he published some, like, for example, this chess title system, because in the US, you can receive different types of titles. Some of those are based on norms. So in order to achieve a particular norm, you need to perform above a certain level. So there's a formula there. Again, as a chess parent, after each tournament, I would immediately calculate whether Matthew will get a norm out of this tournament. So Mark is extremely instrumental in this chess rating system. Well, once you have this kind of chess rating system, so each player has a rating, right? Each player has a rating. So Nakamura's FIDE rating right now is about 2,800. Very few players in the world have this kind of rating. Yeah, my son just crossed 2,300. So, well, if we know the rating from these two players, what will be the expected outcome? So here we just talk about the white players. Right? So here there's this famous formula called ELO formula. So basically, based on the rating for white player, which is A, and the rating for black player B, and then this will be your expected score. Okay, that will be expected score. Recall that if you win, you'll get 1 point. If you draw the game, you'll get half a point. If you lose, you'll get 0. And then Mark has a much more sophisticated formula to calculate the expected score. And the Rosenthal used a simpler formula. And so here we have 2 parameters, C1 and C2. So this C1 parameter is added here because if you play chess, you probably know that if you play white, you have very slight advantage. So that C1 is used to account for that slight advantage. Well, but we still need to know what is the probability of winning a game and the probability of drawing a game. So Rosenthal used this formula again, but there are 3 unknown parameters. So what he did is that, well, you have a lot of games, then you just use some kind of model to estimate those parameters. Well, once we have the drawing probability, which is D1 here, then because we know that the expected score is equal to the probability of winning plus half of the probability of drawing. So once we know the drawing probability, we will know the winning probability. And of course, then we will know the losing probability. There are different types of streaks. There's so-called pure winning streak. That means you win this many games in a row. Okay. There's also another in-between streak. So in-between streak is that we allow at most 1 draw. We allow at most 1. You can win all the games, but we can also allow you have at most 1 draw. In fact, this kind of streak, the difficulty level is lower than the pure winning streak. Non-losing streak, we can do it. We calculate it very easily because that's the opposite of the. You can use the algorithm for pure winning streak. So Rosenthal provide a theoretical lower bound. The idea is like this. So suppose you have a winning streak of 41 games. You calculate the raw probability here. So that's the product of the winning probabilities for these 41 games. So this number can be very small. But because you played so many games, you played like more than 57,000 games, you can partition these 57,000 games into multiple blocks. Okay, then you have this lower bound which takes this value, takes this formula. So you can indeed calculate it. Okay, the reason you can still observe this kind of winning streak because you play so many games. But later I've found that actually this calculation is very conservative, but it's good if the lower bound can already prove that Nakamura didn't cheat. Then of course, if you can calculate the exact probability, you can really prove it more convincingly. So what is the contribution? The contribution here is that we develop a simple computational, very efficient algorithm. I'll show you why it is computationally efficient. And we can calculate the exact probabilities of various types of streaks. So it's not the approximation, the exact probability. So in this talk, I'm going to have time to discuss the pure winning streak. So the question here is, what is the probability of having one, I want to emphasize, one or more winning streaks of K or, the type of K or more games out of N games. So let's consider a very simple example. Suppose you played 10 games and K is equal to 3. So we want to look at these all possible scenarios of having a streak, one or more streaks of winning 3 or more games. Okay. So in this first case, we have 1 streak of 3 games. In the second case, we have a streak of 4 games. And the third case, we have 2 streaks of 3 games. And then the other one, we have 1 streak of 3 and 1 streak of 4 games. And this goes on because there are so many different possible scenarios. So it is, even for that small number, it's not easy to list all possible scenarios. And later on when N and K are large. So N here is like 57,500. And K, you may want to look at up to like 200 games. But what we can do is that we can derive the probability of the complement of that set. So the probability of not having one or more winning streaks or K or more games out of total n games. And here we use the conditional probabilities and recursive derivation. So suppose here we define this event, AMK. So there's no winning streak of K or more games in the first M games. And then, now let's take a look at, move on to the next game. So this is still true if the next game is a loss. Then you don't have a streak, right? Or if the next game is a win, but as long as you can guarantee, you don't have a scenario that, that will lead you to this new winning streak because you have an additional win. So that's the basic idea. And here's a recursive formula to calculate this kind of probability for any M and any K. So that's why we see that this is actually computation very efficient. When we calculate it, we can calculate a big matrix of probabilities, not just one probability. We can calculate all the probabilities for any number like M and any number K. So we can take a look at this two form here, and this is if the second, the next game is loss, and here if the next game is win, what happens? Okay, and this one is a lot more complicated, much more complicated. It took me a lot of time to figure it out. So I'm going to skip it. Well, as a statistician, I'm not a mathematician, I'm not a probabilist, so I don't trust any theoretical results, even my own, without doing any simulations. So here, I did a lot of simulations. I want to check the empirical probabilities versus the true probabilities. So here, I generate like 30,000 games and did it repeated 10,000 times. It's time consuming when you use Monte Carlo. But you can see that in all cases, the true probabilities and the empirical probabilities are very close, up to almost like 30 decimal points. That's good enough. So now I'm a lot more confident in using the algorithm, and this is the case when we allow at most one draw, same story. Okay. Now, before I mention that lower bound is conservative, so let's take a look at an example. So we consider this Nakamura's 41 games in 2020, and the raw probability of winning all 41 games is very small, very small. And if we use that lower bound, it gives you 1.4%. However, based on this algorithm, the exact probability is almost 10 times larger. Okay. Well, the reason is when we use that lower bound, we ignore the scenarios that they have overlap winning games between two blocks. So basically, you omit all those possible scenarios when you calculate the probability. That's why. Now let's take a look at this interesting result from Nakamura's games. Here I just plotted the histogram of the winning probabilities, and most of course, because he's a very strong grandmaster, you can see that all those probabilities are towards congregated towards the right, but there are some very small winning probabilities. I don't think any grandmaster in the world can have that kind of winning probability against Nakamura. So I double checked it. Those are bots. Those are bots. Not even Max Carlsen can do that to Hikaru Nakamura. So all those are engines. So he lost a lot of games to those engines. And then let's take a look at this. So I plotted the probability of having those kind of winning streaks of games. So those games are in the x-axis. And you can see the computation is very efficient. It took 0.2 seconds on my computer. This computer, it's not a fancy and super computer. 0.2 seconds to calculate more than 10 million probabilities for the pure winning streaks. For the in-between, it will take more time. But for pure winning streaks, it's extremely fast. And from here, we can see that there's a very large probability for Hikaru to have long streaks, winning streaks of more than 100 games, and I didn't know that because when I read those papers, nobody mentioned that he had streaks of more than 100 games. And then I double-checked the data. Indeed, he had 2 pure winning streaks, 101 games, and another pure winning streaks, 117 games. But I checked the raw winning probability. Those raw winning probabilities are large. That means in that stretch, all those opponents are very, very weak. So in fact, with this kind of equation, they can actually contaminate the data. Because if you play like a player with rate 1,000, you can have a winning streak 1,000, but it doesn't mean anything. So what I did next is that, well, I want to remove those games. I focus on games that such that the difference in rating is within 200 points. And now you can see the number of streaks is not smaller. He didn't even have a streak of winning more than 15 games. So these numbers are more reasonable. And then I calculated those exact probabilities and found that from this, actually, he should have a fair amount of chance to have winning streaks of more than 15 games, but we didn't observe many. So what happens is that, in my opinion, well, maybe actually he underperformed. He was not cheating, he actually underperformed. All the winning probabilities were overestimated. But either way, he's not cheating. If he was cheating, you would observe a not more, very long winning streaks. Anyway, so I conclude here. So some people ask about the autocorrelation. Actually, Professor Rosenthal addressed this issue in his paper. He found that there's minimal autocorrelation. Unlike hot hand, like in basketball, you probably can make like 3-pointers. Some of those superstars can make like many 3-pointers in a row. So indeed, hot hand exists. But if there's hot hand, that means what we calculated is a lower bound. Again, it will only help you to convince others that Nakamura didn't cheat. And probably having more than one streak, well, that's a very, very hard problem. For pure winning streaks, maybe we can do it, we can figure it out, but it's very hard. Well, in that case, we just use Monte Carlo simulation, but it's very time-consuming. And I did this for chess, but I think it can be applied to any field, any online video games, all kinds of games. As long as there's a win, lose, or draw, we can apply it. I want to thank Eric Albest and Dan Rozovsky of chess.com for providing the data. And here are the references. Thank you.
Thanks, Guoqing. Maybe time for one question, if there are any. All right, we are a little behind, so thanks, Guoqing, one more time.
Thank you.